First of all, thank you for all the panelists who went before me in this session and the one before. It's just been it's been such an inspiration to listen to people who've done so much incredible work in so many different areas. Speaking of different areas, I come from design, and I often feel that I'm at the nexus of so many different issues and so many different domains. The human condition, technology, materials, business forces, sociological trends, big, huge issues facing our cultures, the civilization, and the planet. And often, even within a span of a week, I've spoken to so many different people from different areas that I feel as if I'm on the crossroads, and just by turning around, I'm seeing very different vistas going down each of these streets. And also, of course, the cars coming at me. There's very much that happens too. So just that's a preface to how I'm going to couch what I'm speaking about today. It is from that nexus. It's a very quick glimpse at what we do with materials, and it's more questions than answers. So how do we use materials? And I'm speaking from the standpoint of a designer, because we are so obsessed with materiality. It's such a deeply rooted facet of what we do. But I guess what I'm asking is, who are we in doing this, and how are the materials working on us? So this is something that is rather atrocious. It's about 400 tons of metal that has no business being put together in the first place, and it has no business being aloft like this in the first place, right? And we tend, it's in our nature to defy nature, right? That's who we are. And if it wasn't for that, we wouldn't be 6.7 billion people. And just to put that in context, 200 years ago, we were roughly 1 billion people, right? And if I were, so if I'm a simple person, right? I have simple taste, and like most other designers, I say that give me simplicity and something close to perfection, and I'll be happy as a clam, right? But think, if I were standing 200 years ago, I would probably be deeply envious of a bird, and this hasn't fixed it. I still am, but I would not imagine being able to do this. I would probably be, I would weep with gratefulness if I had 5 minutes of being able to look at the planet from 7.5 miles of altitude. And here, I try to keep my own ecological footprint low, but I think by the end of this year, I would have done 30,000 miles in one of these beasts. And I imagine this scenario. I'm sitting with 300 other people, 7.5 miles above, going to close to the speed of sound, to a place I don't really care about, that I probably need to be there for an hour and a half, and everybody's thinking the same thought, which is how bad the coffee is, right? And what I'm asking myself is, how did we get here? How did we get to this point where this is commonplace, right? How did we get to the point where I can assume that most of you have something like this in your pocket? So that's what I'm asking. So what are other ways, right? What are other things that we do? We definitely find new frontiers, right? This is Spaceship One that made two journeys to space, which is 70 miles altitude in 2 weeks, right? And someday, not too far away, we'll be complaining about the coffee on the way there, right? And look at this. This is transparent concrete. And it's translucent. And this kind of is testimony to, if you make something appealing enough, people will come and hug you, right? So look at how beautiful it is. And then we have this obsession for controlling material. These are MEMS structures, micro electromechanical systems, which are a few hundred microns in size. your hair is probably, I don't have any, but your hair is about 100 or so microns thick. And these are, the one on the right just cracks me up because it's not only a mechanism, but it has other mechanisms controlling those mechanisms. That little lever is basically a mechanism that is keeping these perfect spur gears in plane. And then we celebrate novel processes. This is something that is fused deposition modeling. This thing is made in one single piece. It's grown as a material. And we're so entranced by these possibilities that we express them. And we exploit the materials. This is the Amazon Kindle, and it uses a material which is exactly like paper. It's e-ink, and it doesn't use a backlight. So the brighter the light gets, the brighter you can see it. And it's quick. The moment this material comes up, people find uses for it. And then we stretch the limits of materials that we've had for a long time. Concrete has been around for a couple of thousand years, but in the hands of someone like Calatrava or Pierluigi Nervi, we use these properties in very interesting ways. This is concrete and steel, but it's using very thin wall shell structures to do things that are quite extraordinary. And we mimic nature. Those are structures under the feet of geckos, the feet, which have these very, very tiny hair, which allow them individually to grab onto the tiny little crannies on a surface so that they can climb even on a glass surface, because even a glass surface has those crannies. And on the left is an artificial gecko. It's a robot that is designed by Mark Katkowski and his group from Stanford out here, which climbs a sheet of glass as well. And then we mimic nature in other ways too. On the left is a process, or rather a phenomenon, it's called the lotus effect, where there are very, very small structures at the level of the surface which allow for very different behavior when a drop of water falls in it. It tends to behave more like mercury. And as it rolls around, it picks up dirt, and it's a self-cleaning system. And so the one on the right is an artificial material, but it uses a similar property, so it's self-cleaning. And then we saw so much of this as well, which is we like to stay within our expressions of materiality, and yet we so deeply appreciate nature. Nobody's left unmoved by it, and then we express it in this way. And we are always referring to nature. We find it all around, right? This is a bamboo bicycle, and it has hemp. It has hemp that's being used for the joints. It has for the lugs. So it's just a brilliant bicycle, but it's using the property that because of which bamboo is bamboo. It's this plant of very high aspect ratio. It has to withstand high winds. They clash against each other in a bamboo grove, exactly the kind of properties you can use when you're designing a completely different kind of a bicycle. And this is something where we often steal from nature in very overt ways. This is a valve for a valve replacement surgery. It's a tricuspid or a mitral valve that uses a similar part from a pig's heart, right? And this is something that is in people's bodies, and it was living tissue not too long ago.